Yes, good morning to everyone. I hope I am audible in both classes and you people type it in the chat. Students, yes, is the presentation is visible? Yes, classroom cool? Yes, very good. Okay, so now you will go with the session. Okay, so in the previous class, what topic we have discussed? Previous class, any topic discuss pannumba? Can you type it in the chat? Yes, timer and counter, very good. See the timer bar counter of Intel 8051 microcontroller we have discussed. Fine. So what are the different operating modes of timer bar counter? Can you say? Yes. Can you type it in the chat? What are the different modes of operation of timer bar counter? Yes, mode 0, mode 1, mode 2, mode 3. Fine. We have to know the description of the modes also. Fine. Mode 0 means 13-bit timer per counter. Mode 1 means 16-bit timer per counter. Mode 2 means 8-bit timer with auto reload. Yes. Mode 3 means split timer. Fine. So at the end of the session, we have also discussed how to calculate the count value to be loaded. Yes. Can you people say how to calculate the count value to be loaded? We should not put the desired count directly into the count register. Fine. It is not going to generate the interrupt for the count for which we are writing the program. Fine. See, we have some method. We have some calculation to load the count value. Yes. Yes, very good. Maximum count value in the particular mode minus the desired count value plus 1. Very good. That's the correct answer. Yes. Fine. Similarly, to calculate the desired count value for a required time, we have told one equation. Yes. Can you say what about that? How can we calculate the desired count for a desired time? Yes. The desired count is equal to required time divided by time period of what? Time period of what? Yes, very good. Time period of one mission cycle. Thank you. Fine. So now we'll move into today's topic. Fine. See, we have to know the steps to program the timer bar counter. Okay. Then we will move into the new topic: serial communication and serial UART of Intel 8051 microcontroller. Fine. So today we are going to see about the serial UART of Intel 8051 microcontroller. Before that, what are the steps we have to follow to program the timer bar counter? So this, it is going to help you when you are programming the timer of 8051. Fine. The very first step is you have to stop the timer or counter. Okay, using TRX bit in TCON register. Fine. Is it clear? To program the timer bar counter, if it is already running, what we have to do? We have to stop the timer bar counter using the TR1 and TR0 bit in TCON register. Can you say what about the functionality of TR1 and TR0? Kindly type it in the chat. See, kindly interact. This is the first session. Fine. Today it is the first session. See, I am expecting more interaction from you people. Day by day, our interaction on the kammi aite da podu. Even classroom only வந்து பாத்தீங்கன்னா கம்மி ஆயிட்டே தான் போகுது. Fine. Kindly type it in the chat. Yes, very good. To run or stop the timer. Fine. See, timer run பண்றதுக்கும் stop பண்றதுக்கும் என்ன பண்றோம்? TR1 and TR0 bit we are using. If you set the bit, it is going to run. If you reset the bit, it is going to stop the corresponding timer bar counter. Fine. The very next thing what we have to do is we have to configure the timer bar counter using TMOD register. Fine. So using TMOD register, what are the things you can do? Whether gate control is needed or not, that you can fix. Then whether it is you are going to configure it as timer or counter, that we can do. Then mode of operation. Three things we can configure using this TMOD register. Yes, that is the second step. After you have configured the mode of operation, the very next thing you have to do is you have to load the You have to load the count value that you have calculated. நமக்கு என்ன count value வேணுமோ அது அப்படியே போடக்கூடாது. First we have to calculate using that formula, right? Then you have to substitute in the registers. TLX is going to have a lower 8-bit and THX it is going to have the higher 8-bit. Fine. See, after you have loaded the count value, the next step is run the timer bar counter. Again, to run the timer, we have to use again TR1 and TR0. Fine. Yes. Okay. Now the timer bar counter is going to run. Fine. So what we have to do to get an interrupt? We have to enable the timer overflow interrupts. Fine. The timer overflow interrupt நம்ம enable பண்ணிட்டோம்னா ஒவ்வொரு தடவையும் அந்த டைம் முடிஞ்ச உடனே you will be getting the CPU is going to get an interrupt from the timer bar counter hardware. Fine. Such that you can do any operation. Fine. So these are the 5 steps you have to follow to program the timer bar counter of Intel 80. Fine. Timer ஓடிட்டு இருக்கப்பே நம்ம கான்ஃபிகர் பண்ணனும்னா it is going to produce some abnormal operations. Fine. So we have to stop the timer, we have to configure the mode of operation, we have to load the count value, then we have to start running the timer. Fine. Clear? Also you can check the overflow flag bit TF1 and TF0, okay, till it is getting set. Fine. If it gets set, what it means? The time generation is over. Fine. But this particular thing is not preferred when you are going for hardware timer. This particular thing is not preferred because the CPU is again engaged in checking this flag bit. Fine. So we have to use only the interrupt, timer overflow interrupt we have to enable. Fine. If you are doing the first thing in the step 5, your processor is again going to be engaged in the particular operation. Yes, whether the timer overflow occurred or not, your processor is going to check now. Fine. So the second one we can follow, enable the timer overflow. Fine. So these are the 5 steps you have to follow, program the timer bar counter of 8051. Fine. Next. So how many timers are available in 8051? What is the size of each timer? Kindly type it in the chat. How many timers we are having and what about the size of the timer registers? Yes, 2 timers. What about the size? Very good, 16-bit. Fine. Next, how many modes of operation of timer bar counter available in 8051? So, எத்தனை mode of operation இருக்கு total? Yes, very good. 4 modes of operation. How many clock pulses taken by timer of 8051 for an increment in its count value? Timer எத்தனை clock pulsக்கு ஒரு தடவை increment ஆகும்னு படிச்சோம். Yes, very good. 12. Why 12? Why it is 12? Because it is the time period of what? 12 clock pulse is going to form 1 machine cycle. Very good. Fine. Then when timer bar counter generates overflow interrupt? First of all, what do you mean by overflow? Timer overflow means what? Kindly type it in the chat. Yes, when the value changes from maximum to minimum, that we call it as timer overflow. During that time, timer overflow interrupt occurs. Yes, whenever the count changes from maximum value to minimum value. Name the SFRs we have used to program the timer bar counter of 8051. What are all the SFRs we have discussed so far regarding the timer bar counter? Yes, TCON, very good. Then TMOD, very good. Then for loading the count value, we have 4 registers, 2 for each timer bar counter. Yes, TL0, TH0, very good. Then TH1, TL1, fine. Thank you. Fine. So now we will get into the serial UART of Intel 8051 microcontroller. Okay, before getting into the serial UART of Intel 8051, we have to know some basic thing about the serial communication. Fine. So first we will go with the general concept regarding the serial communication. Okay, then we will go with the serial UART of Intel 8051. Fine. As of now, you people know one thing about the serial communication. Can you type it in the chat? What about the major difference between the serial and parallel communication? In the case of serial communication, your data bits are going to be transferred through a single line, that we call it as serial communication. Fine. So communication refers to generally transfer of data between 2 points. General communication na transferring information between 2 points. Okay. So it can be serial or parallel. Fine. So the difference between serial and parallel communication are listed here. Fine. So in the case of 8085 processor, 8 bit of data transfer at a time. Correct? Fine. If you want to transfer an 8 bit of data, you are having a 8 bit data bus. That means 8 parallel lines you will be having. Correct? Here, 1 bit of data is transferred per clock. Fine. So one clock pulse ku 1 bit da nama inge transfer panna porom. That means what? Here, in a single clock, the entire 8 bit can be transferred through 8 parallel lines in this example. Fine. But here in the case of serial communication, we are going to transfer bit one after the another for each clock pulse. Fine. So here we need 8 conductor lines to establish the data transfer. Fine. Here we need only 2 conductors. Okay, 2 lines. See, one is for transmitting the data, the other one is for receiving the data. Fine. Here, as we are transferring the data in single clock, 8 bit, so here the data transfer is faster. So here the data transfer is relatively slower. It's not much slower, it is relatively slower. Fine. The main advantage of parallel communication is it is used for short distance communication. Fine. It cannot be used for longer distance. Why? If I use parallel communication for longer distance, what about the drawback? Yes, can you type it in the chat? Yes, cost. How the cost is going to increase? As we need 1 line for each bit of data in the case of parallel communication, we need n number of lines, okay, to transfer an n bit data. Okay, to some distance it can be used. Fine. That's why it is used for shorter distance applications. Fine. Whereas in the case of serial communication, we can go for it for a longer distance. Fine. The one more disadvantage in the parallel communication is as each lines are parallel and it are twisted together and available in a wire, sometimes the current going through a line may produce some effect on the another line. That means due to some electromagnetic force, okay, the data is going in the other path may get disturbed, fine, may get be interfere. So that's the another disadvantage in the case of parallel communication. Fine. So here in the case of serial communication, it is relatively slower, but for long distance we can go for it. Fine. Okay. So serial input output, how it is going to be there? So in a serial I/O, the parallel data is to be converted into serial data using shift register. I hope you people studied in the digital electronics. Yes. So digital electronics already we have the parallel data can be shifted one by one so that it can be available as a serial data. Fine. So parallel and serial out shift register we have studied. Yes. The serial output is going to be sent over a single line. Fine. If you are transmitting an 8-bit parallel data, first it has to be converted into serial data. Then we require 8 clock pulses to transfer the 8-bit data. Fine. See, each clock pulse will be sending 1 bit of data. Fine. See, as we are transmitting the bits one by one, fine, one after the another serially, it is termed as serial communication. In the case of parallel communication, in a single clock pulse, the 8-bit data is traveling through 8 lines. Fine. See, for example, I am always speaking 8-bit, 8-bit. Fine. It need not to be always 8-bit. The parallel data communication can be of 8-bit, 16-bit, 32-bit, 64-bit, whatever it may be. Fine. Fine. The main theme I am saying is the entire n bit of data can be transferred in single clock in the parallel communication. In serial communication, we need n clocks to transmit n bit of data. That's the thing I want to see. Fine. So on receiving end, the parallel data is again, I mean, on the receiving end, the serial data is again converted into parallel data. Fine. There is a mistake here. Correct it. The serial data is converted to parallel data. Yes. So here you can see, here the 8-bit parallel data is converted into serial data using parallel to serial converter. Yes. So you will be having a clock pulse. Fine. Why clock pulse we are having here? On each clock pulse, 1 bit of data is going to be sent as output through the serial line. Fine. At the receiving end, you can see the serial data is converted into a parallel data again, so that whatever the data you are transmitting from the transmitter side, it is going to be received at the receiver side. Fine. But there should be some rules, set of rules followed by both devices, the transmitting and receiving device. That we call it as protocol, communication protocol, serial communication protocol. In any communication, you will be having some set of rules. Fine. That must be followed by both the devices. That we call it as protocol. That we call it as protocol. Fine. Here, one thing I want to ask you. Here also I am having clock pulse. Here also I am having clock pulse. Fine. If both clock pulses are at different frequency, what is going to happen? If both clock pulses are at different frequency, what is going to happen? Whether we receive the data without error, whether we receive the proper data, yes, because what we are doing here is a serial communication. The time at which you are releasing a data, a bit of data, during the time interval, it has to get into the serial to parallel converter. Yes, otherwise we will be having a mismatched data or error data. Fine. Is it clear? Then one more thing we have to consider, apart from the transmitting line, we have to produce a common ground for both the system. Fine. So meaning in when I am going to transmit a data from one device to another device, I need one line for transmitting the serial data and one more line for a ground reference. A common ground must be established between the two systems. Fine. They can be powered with individual source, but their ground should be common. Otherwise, also you won't be receiving the proper data. Fine. Fine. So this is the general theme of the serial communication. In any serial communication, the parallel data is going to be converted into serial data. Okay, then it is going to be transmitted over a line. Fine. At the receiving end, this serial data is again converted into a parallel data. Fine. So this is the main functioning of the serial communication. Okay. Now, you will have different types of serial communication based on different aspects. The very first thing what we are going to discuss is the direction of communication. Based upon the direction, the communication are classified into different types. So one is simplex. Okay. So in the case of simplex, the communication is only from one end. Fine. That is one-way communication. Simplex means one-way communication. That means you can always transmit a data. The other device it is always going to receive. There is no communication in the reverse direction. See, one-way communication. Simplex we can call it as one-way communication. Fine. Data transfer takes place in only one direction. Fine. Next, there is no possibility of data transfer from the other end. Already we have told in the previous point itself. Fine. Can you people say an example for this? Can you people say an example for this? Can you people say an example for this? See, sometimes our class is going to be like that. See, now there is no communication from that side. Fine. Okay, can you say some real-time examples? Yes, can we consider the yes, TV and remote? Okay. See, from the remote we are sending some information to the television. Fine. Yes, very good. Is there any other proper application you will be having? Television, you can say. See, from the broadcasting station, they are sending the, they are telecasting the channels. Fine, we are receiving. That we can say it as one-way communication. Yes, so that is simplex. Fine, next. So here one system is going to be a transmitter, the other it is going to be a receiver. Fine, it is one-way communication. Next, in the case of duplex, again we are having two different classifications. One is half duplex, the other one is full duplex. Fine. Duplex means the data transmission can be in either direction. It is not like in the simplex. In the case of simplex, it is only one-way communication. In the case of duplex, it is two-way communication. But the duplex is again divided into two categories: half duplex and full duplex. Fine. In the case of half duplex, the data transfer can be in both directions, but there is no simultaneous data transfer in both directions. That means only one direction can be allowed at a time. Fine. But any point of time, the data transfer will be active only in one direction. Okay. So the best example what we can say is walkie-talkie. Fine. The policemen, they usually used to have some device. Okay. So in that, after they have finished some message, saying some message, they will say over. Correct. That over indicates I have transmitted the data. Now you can speak. That's the meaning for that. If both people are speaking simultaneously, they won't be receiving the information. Fine. That is the best example for the half duplex communication. Both person can transmit as well as receive, but cannot be done simultaneously. Yes, is it clear to everyone? Is it clear to everyone? Yes. Okay, what about in the case of full duplex? In the case of full duplex, the data transfer can be simultaneously on both directions between two systems. Fine. This we call it as full duplex. So you can see in this picture. Fine. Terminal A, it is a transmitter. Terminal B is going to be a receiver. So the communication is only from one direction, from A to B. In the case of second thing, the communication is in both directions, but only one at a time. Fine. As we are having only single channel, single wire, terminal A can transmit data to B at one point of time. Once the data transfer is over, now B can transmit the data to A. That means the data communication is bidirectional, but only one direction is permitted at a time. Fine. In the case of the last thing, last diagram you can see, when the device A is transmitting the data and B is receiving, at the same time it can also transmit the data to A. Yes, is it clear? Out of this three communication, which type of communication our 8051 UART follows? Already we have told it in the future itself. Yes. Yes, very good. Full duplex. That means we are having two pins, TX and RX. TX for transmitting the data and RX for receiving the data. That means when your microcontroller is transmitting the data, at the same instant it can also able to receive the data. Right? Both can be done at a time. Is it clear to everyone? Yes. So the 8051 UART is full duplex. That is the very first point I want to say. Right? So for that we have gone through this. Is it clear? Shall we proceed? Will we proceed further? Yes, fine. Okay. Now the second classification is based upon the clock source. Fine. Asynchronous and synchronous. Okay, there are two types of communication. based on the clock input. Fine. How we are providing the clock source to both the transmitter and receiver. That we call it as the classification is asynchronous and synchronous communication. First, we will go with the asynchronous mode of data transfer. Okay. First, we will go with the transmitter end. At the transmitter end, how the data is going to be transmitted. Fine. First, we will go with it. Fine. So this mode is character-oriented data transfer. That means one byte of data is transferred at a time. Fine. So that we call it as frame அப்படின்னு சொல்லுவோம். ஒரு frameல 8-bit data தான் நம்ம வந்து maximum send பண்ண முடியும். Fine. In some cases, it is allowed to have 9-bit of data. Later point of time, we will learn why 9-bit. Fine. So this mode is character-oriented. Fine. Per transfer, you can transmit an 8-bit of data in a frame in general. Fine. When the data is not transmitted, fine. First, we will start with this. When there is no data transmission, the transmission line must be pulled high by the transmitter. So this we call it as marked position. Fine. General transmission நடக்காதப்ப என்னோட transmitter என்ன பண்ண போகுது? It is going to keep the line high. Yes, that we call it as marked position. நல்லா கவனிக்கணும். As it is a serial data, transmitter transmission start பண்றதுக்கு முன்னாடி it has to say something to the receiver. Correct? But initially, என்னோட transmitter எப்படி இருக்கு? It is maintaining the transmitting line to the high logic. That indicates it is not transferring any data now at this point of time. Fine. Any clock pulse, any number of clock pulse, it is going to be maintained high initially. Fine. This we call it as marked position. Fine. When the transmitter wants to transfer some data, what it is going to do is, it is going to send one start bit. What it is going to send? It is going to send one start bit. One start bit means for one clock pulse duration, it is going to maintain the transmitting line as flow. Fine. What I have told earlier, when it is not transferring any data, it is going to keep the pin high only. Fine. When it want to transfer a data for a one clock pulse, it is going to make the line low. Is it clear to everyone? Is it clear to everyone how the data transfer is happening here? Generally, the transmitting line is going to be maintained high when there is no transmission. That we call it as marked position. When it want to transfer some data, it must pull the transmitting line low for one clock pulse. Fine. So that we call it as one start bit. The start bit is low signal. The start bit is used to synchronize the transmitter and receiver. Fine. The very first thing what I have to say is, in the case of asynchronous communication, you can see this diagram. Whether the transmitting device and receiving device are provided with same clock pulse, ரெண்டுத்துக்கு ஒரே clock pulse தான் போதா இல்ல different clock pulse போதா? Yes. Can you people say? In this diagram, what about the clock source? Yes, the clock sources are different, but the frequency of clock is not going to be changed. Either in the asynchronous communication, fine, the frequency of operation is going to be same, but the clock sources are different. Fine. So asynchronous communication அப்படினு சொன்னா clock source வந்து டிஃபரண்டா இருக்கும். அப்படினா மீனிங் என்ன? இது எப்ப சென்ட் பண்ணுதுன்றத ரிசீவருக்கு சொல்லணும். Fine. That's why we are transmitting a start bit initially. Before transmitting the data, it must keep the line low for one clock pulse. Okay, that we call it as one start bit. Fine. Once the start bit is received at the receiver, okay, it knows, okay, now the data is going to be coming. Fine. So after the start bit, the LSB is going to be transmitted first. Fine. So the 8 bits are going to be transmitted for each and every clock pulse. Fine. Over clock pulse, over bit வெளியில போகும், which is going to be the very first bit. In the bit first transmit ஆகும் 8 bit data la. Kindly type it in the chat. The LSB bit. Fine. See, out of the 8 bits, the least significant bit D0 is going to be transmitted first. first clock pulse la D0 போகும், next clock pulse D1, D2, D3 up to D7. Fine. After transmitting the 8 bits, it is going to transmit an optional bit that we call it as parity bit. Fine. இப்போ நான் transmit பண்ண டேட்டால எரர் இருக்கா இல்லையான்றத சொல்றதுக்கு தான் இந்த parity bit. Fine. In digital electronics, we people study, correct? You people study parity generator, parity checker. படிச்சிருக்கோம், கரெக்ட்டுங்களா? parity generator எங்க யூஸ் பண்றோம்? Transmitting side ல யூஸ் பண்றோம். That means what? It is optional. Fine. If you want, you can have this. Fine. First என்ன பண்றோம்? Transmitting line high ல maintain ஆகுது. Next, for 1 clock pulse duration, the line is pulled low. Okay. So after the start bit, it is transmitting the 8-bit data. Okay. For each clock pulse, it is transmitting 1 by 1 bit. Fine. The very first bit it is transmitting is LSB. The last bit it is transmitting is MSB. After transmitting the 8-bit data, the parity bit it is going to be optional. Fine. That is decided by the transmitter and the receiver. See, இப்போ எனக்கு parity check பண்ண போறோமா இல்லையான்றது transmitting and receiving device both has to be from the rules. Fine. எனக்கு transmitting device parity bit send பண்ணா கண்டிப்பா receiving device என்ன பண்ணணும்? Parity check பண்ணணும். The 9th bit it is going to be received as a parity bit. Fine. Now you people can understand. 8-bit is the universal thing. The 9th bit it is going to be a parity bit usually. Usually the 9th bit is a parity bit. Is it clear to everyone? Is it clear to everyone? Yes? Yes. Fine. See, after transmitting the data and the parity bit, it is going to send the stop bit. Fine. So the parity bit is followed by 1 or more stop bit. Generally 1 or 2 stop bits. See, 1, 2 அப்படின்னு சொல்றதுல meaning என்னன்னு பாத்தீங்கன்னா the number of clock pulse. Fine. For 1 clock pulse, minimum 1 clock pulse க்கு திரும்ப அந்த transmitting level line வந்து high போயிடுச்சு அப்படின்னா the data communication. I mean the receiver know this is the end of the data. So இதுக்கு முன்னாடி clockல வந்ததோட data and parity bit முடிஞ்சிருச்சு. Fine. So இதுக்கு அப்புறம் நமக்கு திரும்ப எப்ப start bit வருதோ now only at that point of time only the receiver is going to be again receiving the data. Fine. Is it clear to everyone? Can you say what are the things I have told? The very first thing is if there is no transmission, the transmission line is going to be high. Fine. When the transmitter want to send some data, it has to pull the transmitting line low for 1 clock pulse. Fine. The receiver know such that the receiver know the line high le da irukudhu, low போகுது அப்படினா meaning என்ன? It is going to have some data from the transmitter. The receiver is going to have some data from the transmitter. Fine. Once start bit வந்துருச்சு அப்படினா the next 8 bits it is going to be a data. Fine. This entire thing we call it as frame. Start bit, data, optional parity bit, stop bit. From start bit to stop bit, we can say this format we can call it as frame. The entire thing is நம்ம என்ன சொல்றோம்? Frame அப்படினு சொல்றோம். Fine. ஒரு ஃப்ரேமுக்கு 1 byte of data transmit ஆகும். Fine. So this is the role takes place in the transmitter end. Receiver end ல என்ன நடக்குதுன்னு பார்க்கலாமா? Yes. See, after this stop bit, same high level is maintained for marked position. திரும்ப அடுத்த bit transmit பண்ற வரைக்கும் திரும்ப marked position போயிடும். See, this is the role of the transmitter end. Receiver end ல என்ன நடக்குதுன்னு பார்க்கலாம். In the case of receiver end, the receiver check for marked position. Marked position ல இருக்கான்னு check பண்ணிட்டே இருக்கு. Fine. When a low is detected, அந்த லைன்ல ஒரு low detect ஆனிச்சு அப்படின்னா initial. Fine. When a low is detected, the line is checked after half bit time. What is the meaning for this? ஒரு clock pulse ல திரும்ப again half the duration. Fine. In that one clock pulse, half the duration, half the clock pulse, when it reaches half the clock pulse, the receiver again checks whether the line is still low. Fine. This ensures this is going to be considered as a valid start bit. Yes, sir. In the condition வச்சிருக்காங்க அப்படின்னு பார்த்தோம்னா due to some noise, fine, due to some noise in the environment, transmission line la sudden ஒரு low pulse generate ஆக வாய்ப்பு. Fine. This that should not be considered as a start bit. Fine. So for that, how it is designed? When it detects low, it waits for half the clock period. Once half the clock pulse timing is reached, again it check the line. Still, if the line is low, it is considered as a valid start bit. I hope now you people can understand. Fine. Okay. Once start bit வந்துருச்சுனா அடுத்து என்ன பண்ணும்? The receiver, after the start bit, the data is received. Okay. So after the start bit, the data is going to be received. So 8 bits to receive பண்ணியாச்சு. Fine. Then after the stop bit, it goes to initial mark state. Fine. So in the stop bit நமக்கு வந்ததுக்கு அப்புறம் திரும்ப என்ன ஆகும்? திரும்ப marked position போய்டும். So again the receiver, it is going to check for low pulse. Fine. So this process is repeated for every byte of data transmitting from the transmitter side. Fine. Receiver la இதே process தான் நமக்கு நடக்கும். So the asynchronous data format consists of start bit, yes, data bits, parity bit, which is going to be optional, and stop bit. This entire format we call it as frame. So one byte data send பண்றதுக்கு it is going to use one start bit, then 8 bit of data, then optional parity bit, then finally stop bit. This entire thing we call it as frame. Fine. So the clock at both the receiver and transmitter end are separate. Transmitter side la நம்ம different clock source use பண்ண போறோம், receiver side la different clock source use பண்ண போறோம், but they operate at the same frequency. That's very, very important. Fine. Even though the clock sources are different, the frequency of operation is going to be same. So the rate at which the bit transfer is called baud rate. The rate at which the bits are transmitting in the serial communication, that we call it as baud rate. In other words, we can say the number of bits transferred per second. Fine. This is usually decided in advance to maintain the synchronization between the transmitter and receiver. Fine. So இது வந்து transmitter receiver ரெண்டுமே first I have told you protocol. In that protocol, it is everything. Okay. So whatever I have told, start bit இப்படிதான் இருக்கணும், data bit இப்படிதான் வரும். Fine. So this is the communication protocol, UART. Fine. Universal asynchronous receiver transmitter. So that is the thing available in our 8051 microcontroller. Now you people say which type of serial communication your 8051 microcontroller is having, serial port your 8051 microcontroller is having, whether synchronous or asynchronous. Yes, whether it is going to have a synchronous communication or asynchronous communication. See, it is going to have, it is used, yes, it is used asynchronous communication. Fine. See, at what speed your 8051 microcontroller transmitter is sending, the same speed the receiving device also follow. Fine. So that we call it as baud rate. Speed of communication in terms of baud rate. Fine. So we will go with it later point of time. So in the baud rate la eppadi nama program pandrathu, fine, eppadi fix pandrathu, that and all we can see later point of time. Fine. Okay. As of now, what we have learned, asynchronous communication means different clock source but operating at same frequency must be there. Fine. So transmitting device, it is going to make the line high till it is going to start the communication. Fine. Once it is going to start the communication, it pull the line low for 1 clock pulse, then transmitting 8 bits after the 8 clock pulse. Okay, then optional parity bit it is going to transmit, then finally it is going to send the stop bit. Fine. This entire thing we call it as a thing. So this is the thing happening in the asynchronous serial communication. Now we will go with the synchronous. Okay, before that you can see this diagram. So this is the transmitter and this is going to be the receiver. Okay, first it is going to make the line high. Fine, you can see in this diagram logic 1 is maintained initially. So this is going to be start bit. What I told about start bit means for one clock pulse duration it is maintaining the line as low. Fine, then it is transmitting data bit 0, 1, 2, 3, 4, 5, 6, 7. 8 bits are transmitted. Fine. Here in this diagram, the parity bit is not mentioned. Okay. As I told, the parity bit is optional one. Fine. Okay. Then it is going to have the stop bits. Here in this case, it is having 2 stop bits. Fine. Minimum 1 stop bit must be present. Here you can see. So the data bits are character. What are the possible size of the character you can send is 5, 6, 7 or 8. In some cases it is going to be 9 when considering the parity bit. Fine. Then the size of the start bit must be 1 bit only. That means during 1 clock pulse it is going to be maintained. Fine. What about the stop bit? 1, 1.5 or 2. It is going to vary. Fine. Then parity bit. Either it is going to be odd parity bit or even parity bit. That is depending upon the programming. Fine. See, depending upon your application, transmitting and receiving, both should obey this protocol. See, in the rules alone, once form panita, rendu device enna panna follow pannu. Fine. See, it is universal to all the UART protocol devices. That's why it is termed as universal asynchronous receiver transmitter. Fine. எந்த சீரியல் UART நீங்க எடுத்துக்கிட்டாலும் அதுல இந்த கண்டிஷன்ஸை ஃபாலோ பண்ணும். ஸ்டார்ட் பிட், டேட்டா பிட், optional parity bit, then stop bit. Fine. Then baud rates. These are the different baud rates, standard baud rates that can be followed. Fine. So the most common thing எது அப்படினு பாத்தீங்கன்னா 9600. இந்த baud rate தான் most common use பண்றது. Fine. Really note down this. In most of the application, this baud rate is commonly used, 9600. Fine. Okay, now we'll go with the synchronous communication. So in the case of synchronous communication, a packet of data or block of data is transmitted serially. So inga nama enna sonnom, character oriented sonnom asynchronous பொறுத்த வரைக்கும். Here block of data we are going to transmit, but regular interval we are going to send a word called sync character. Sync character அப்படினா meaning என்னன்னா ஒரு specified bit pattern. Okay, predefined bit pattern. It is going to be sent at regular interval between the block of data transmitted. That indicates whether we are having any error in the communication or not. Fine. So each packet of data can be of n size, n bit. Fine. So each blocks are transmitted one after the other serially. Fine. So before transmission of data, some special characters are sent that we call it as sync character. Fine. These are called synchronization character. So the short I will sync character. I will type it in the chat. SYNC, sync character. Sync character, synchronization character. Fine. So in every communication understand pannikku ipoda start agudhu. First, the sync character, the transmitter is going to send the sync character. Receiver edukku wait pannittu. It is going to receive the bits of data and convert it into a parallel data, and it is going to compare till the sync character is arriving. Fine. So the sync characters are constantly checked. If they are matching, then the data is accepted. Otherwise, the receiving side will request the transmitter one more time to send the data. So the clock to both receiver and transmitter are same. Fine. Even if there is a small mismatch, the data will be wrong. Fine. See, same clock தான் நம்ம கொடுக்க போறோம். So அதனால same frequency தான் நமக்கு போக போகுது. So there won't be any possibility of this mismatch. Fine. In the case of synchronous communication, the clock source must be same. Transmitter க்கு என்ன clock source யூஸ் பண்ணோமோ அதே source தான் receiver க்கு கொடுக்க போறோம். Fine. So that's it about the synchronous data transfer. Here you can see same clock is provided to the transmitter as well as the receiving device. Fine. First it is sending the sync character, then it is sending many bytes of data, data 1, data 2, data n. Fine. After it sends the n bit of data, it again sends the sync character, then it is going to send the block of data. Fine. When compared to UART, this particular protocol is much faster. Okay, there we are having start bit, parity bit, stop bit, many things. Fine. Here, for a block of data, you will be going to have only 1 byte of sync character. Fine. There, for every 8 bit of data, you will be going to have minimum 1 start bit, 1 stop bit. Fine. So this is the case for synchronous serial communication. See, based on the direction, we have classified into simplex and duplex. Duplex is further divided into half duplex and full duplex. Okay, so those are based on the direction of communication. Fine. The synchronous and asynchronous communication is based on the clock source. If you are providing the same clock to both the devices, it is called to be synchronous communication. In the case of asynchronous, we are having different clock source, but operating at same frequency. That's very, very important part. Okay, see, that's all about the basic things you have to know about the serial communication. Fine. So now we people understand what kind of communication your 8051 is going to have. Serial communication it is going to have asynchronous and full duplex UART. Okay, so full duplex UART. Fine. Full duplex, that means both directions can send as well as receive data. Bidirectional communication at simultaneous time. Fine. Then asynchronous communication. It is having asynchronous communication. Fine. Now we'll go with the 8051 serial UART. So the 8051 microcontrollers have a full duplex serial UART which can transmit and receive serial data simultaneously. So it can be operated in 4 modes at variable bar. Fine. See, in the 8051 UART on the 4 different modes will operate panna. That we will go one by one. So the serial data is received at RxD pin, okay, and the transmitting data is going to be through TXD pin. So RxD is input pin or output pin. RxD of your microcontroller, whether it is going to be input pin or output pin. Kindly type it in the chat. Yes, very good. What about TXD? What about TXD? Yes, very good. Out. Fine. See, we have to one thing. Fine. See, when we are going to have the serial port, we are going to use the serial port. We cannot use the entire port 3 for IO devices. Fine. Is it clear? See, now serial communication வேணும்னு சொன்னோம்னா தனியா அதுக்கு பின் கிடையாது. Port 3 ஓட 0th pin and the first pin. It is used as RxD and DXD. That means what? You cannot use those pins for connecting input-output devices. Fine. See, RxD is the input pin and DXD is the output pin. Fine. So this is the representation of the serial port of 8051 microcontroller. Fine. So one pin on the input, another pin on the output. Fine. See, data is received through the input pin and data is transmitted through the output pin. Generally, fine. Generally, நீங்க எந்த microcontroller படிச்சாலும் அதுல transmitting and receiving pinக்கு இந்த மாதிரி ஒரு நேமிங் கொடுத்திருப்பாங்க. TXD stands for serial data transmitting pin. RxD stands for serial data receiving. Fine. Okay. Now, this is very, very important. I have told you it is a full duplex UART. Fine. So we are having 2 pins. Fine. Okay. Now clearly look about here. Here we have a 8-bit internal bus. Fine. Here we have a 8-bit internal bus. Fine. So whatever the data you are going to transmit within the microcontroller, it is going to be parallel only. Fine. When it is going to be transmitted, it is converted into serial data. Yes, correct? Is it correct or not? Already. Already we have discussed how the serial communication can be done. Transmitting end la parallel to serial conversion nadakanum, receiving end la serial to parallel conversion nadakanum. Yes, is it clear to everyone? Is it clear to everyone or not? I need to type it in the chat so that I can know. Yes, fine. Okay. See, now see this diagram. For example, if I am writing some data to the SBUF register, fine. Generally, the data what we are going to transmit or receive, it is going to be through the SBUF register only. Fine. A very interesting thing I want to say is, you will be having two serial buffer register. One is write only, the other one is read only. Fine. You have to understand this very, very carefully. Fine. When you want to transmit some data, what you will do? You will write the data to the SBUF register. At that point of time, this register will get selected. Fine. When you use the SBUF as a source register, at that point of time, SBUF write only register is going to be selected. Fine. Similarly, if you try to read the data from SBUF, fine. If you try to read the data from, sorry, I have mistakenly told. If your SBUF register is destination, then write only SBUF will get selected. Sorry, fine. When you are writing something to the SBUF, it will write to SBUF write only register. Fine. If you try to read a data, fine. At that point of time, SBUF read only will get selected. Physically, there are two registers, but name of the register is going to be SBUF. Fine. Up destination program instruction SBUF destination use pannina, write only SBUF register will get selected. If you use SBUF as a source, then read only SBUF will get selected. Fine. So rendu register irukkiradanaala da idu enna solrom, full duplex appdin solla mudiyum. Fine. So inga nama transmit pannakudiya data inga nama eludilla, receive agarakudiya data enga varum, இந்த shift register valiya vande ஒரு parallel 8 bit data vanda odane it is copied to SBUF read only. Fine. So here, whatever the data we are transmitting, it is going to be written into the SBUF write only register. Fine. Then after each clock pulse, one by one bit, it is going to be transmitted. At the same instant, it can able to receive the data. Fine. For each and every clock pulse, it is going to receive the data. See, one more very important thing. If I am fixing the baud rate as 9600, say for example, at what speed it is sending the data, at which baud rate it is sending the data, the same speed only it is going to be receiving the data. Fine. Carefully understand this thing. Baud rate அப்படின்றது transmitter ஒன்னு receiver ஒன்னு நம்ம fix பண்ண முடியாது. Fine. When you are fixing the baud rate of your 80 serial UART, the transmitting baud rate is going to be same as the receiving baud. Fine. Is it clear to everyone? Fine. இங்க நமக்கு ஒவ்வொரு பிட்டா வெளியில transmit ஆகுது. Fine. So the dotted line போட்டுக்குது within the microcontroller. Fine. So the வெளியில உள்ள signals எல்லாமே outside. That means DXT and RXT are the physical pins available in the microcontroller, which are nothing but port 3 pins. So it has two buffer register with same name as SBUF. One is read only register, the other one is write only register. Fine. So read only அப்படின்றது எதை ஹோல்ட் பண்ணுது, received byte ஹோல்ட் பண்றதுக்காக யூஸ் ஆகுது. write only அப்படின்றது transmitting byte ஹோல்ட் பண்றது. Fine. Okay. Now transmission of a byte of serial data. So already நம்ம அங்கே பார்த்தாச்சு. So writing a byte of data in SBUF initiate the data transmission through TXD pin. நல்லா கவனிக்கணும், நீங்க ஒரு டேட்டா, one byte of data, if you write into the SBUF write only, at that point of time serial communication automatically start ஆயிடும். Fine. Fine. நீங்க டேட்டா வச்சுட்டு enable தான் பண்ணணும் கிடையாது. Writing a data into the SBUF write only register itself enable the transmission. Yes, is it clear? When you are writing a data to SBUF write only register, it initiates the data transmission. What are the things will happen now? Based on the mode of operation of the UART, data will be transmitted. As I have told, 4 modes of operation has been பார்த்தோம். So based upon the different modes, the data is going to be transmitted in different way. Fine. So after transmission of the byte, an interrupt is generated to the CPU. That we call it as transmit interrupt. Allah gavanikkanum, I am placing the data into the SBUF write-only register, so it start transmitting the data based upon the mode of operation. Fine. Once the entire data, 1 byte of data, it got transmitted, your microcontroller CPU is getting an interrupt from the serial hardware module. That is to indicate for what? 1 byte of data is transmitted successfully. Fine. That indicates the data byte is transmitted to the receiving end. That is the meaning for this. Is it clear to everyone? Is it clear to everyone? Yes or no? 1 byte of data, நீங்க கொண்டு போய் SBUF write only ல எழுதின உடனே transmission start ஆயிடும். Transmission முடிஞ்ச உடனே the 1 byte of data transmit ஆகி முடிஞ்ச உடனே your microcontroller will getting interrupt called transmit interrupt. Fine. Okay. So the transmit interrupt indicate the CPU that a byte written on SBUF is transmitted successfully. That's the meaning for this. Okay. So if the CPU want to transmit another byte, it can be transmitted by writing it in SBUF again. See, if I want to transmit n byte of data, one byte I will do my own work. Fine. The CPU is going to do its own work, regular routine. Fine. After the transmission of 1 byte, again it is getting an interrupt. Again it is going to place the data. So this is going to be happen till all the byte of data are going to be transmitted. Fine. Okay, next. Reception of a byte of serial data. If the reception of serial data is enabled, that's very, very important. Transmission enable panna thevilla. Why? But in the case of receiving a data, you must enable it. Transmission enable pannu avasiyam kedai, but reception vandu nama enable panni da agum. Why? Why? Who is going to transmit? Who is going to transmit? Your 80 ton microcontroller, it is going to be transmit, correct? See, when you want to transmit a data, what you are doing? You are placing a byte of data in the SBUF register. That means it is under your control. Fine? But reception is not under our control. Fine? எனக்கு இப்போதான் டேட்டா ரிசீவ் பண்ணணும் அப்படின்னா நம்ம வந்து என்ன பண்ணலாம்? We can enable or disable. Fine? வர்ற serial டேட்டாவை நம்ம அவாய்ட் பண்ணணும் அப்படின்னா என்ன பண்ணணும்? Reception has to be disabled. Fine? We don't know at what point of time you are going to receive a data. Fine? So if you want to receive a data byte at this point of time, you have to enable the reception. Fine? Transmission நம்ம ஸ்டாப் பண்ணணும் அப்படின்னா நம்ம டேட்டா போடாம இருந்தாலே போதும். ஆனா ரிசப்ஷனை ஸ்டாப் பண்ணணும்னா we have to be provided with the provision. Fine? Okay. So if the reception of the serial data is enabled, then serial data received at RxD are getting shifted into the shift register. Fine? ஒரு shift registerல ஒவ்வொரு பிட்டா வந்து கலெக்ட் ஆகும். After a byte is received in the shift register, it is moved to SBUF read-only register and an interrupt is generated to the CPU. That indicates a byte of data is received. That indicates a new byte of data is received and stored in SBUF read-only register. Fine? Is it clear to everyone? Is it clear to everyone? Yes. Transmit பண்ண போறப்ப நான் byte போட்டா transmission start ஆயிடும் அதுவே. But reception enable பண்ணனும்னா we have to do it through programming. Fine? No need to enable the transmission. Writing a data itself enabling the transmission. Fine? Whereas in the case of reception, if you don't want to receive any serial data, you can disable the serial reception pin and disable panni vechukkalam. Fine? Okay. Now, the CPU can read the data received in the SBUF and it can be processed. The interrupt vanda udane enna pannikanum CPU. It has to read the data. Fine? That's it. So, enna SFR inge irukku appdin paathomna, we are having 2 SFRs mainly. Okay. Actually 3, but adula rendu da main ah nama use pannom. Fine? SCON, SBUF, PCON. Fine? Why SCON register is bit addressable? Can you people say? Can you people type it in the chat? Why SCON SFR is bit addressable? See, whichever SFR whose address ends with, yes, yes, its byte address ends with 8. 8 or 0 la pudunjale enna sollirkom bit addressable SFR. Fine. So the SCON register oda purpose enna appdin pathina to control and configure the mode of operation of serial UART. Serial UART enna mode la operate agum, as well as it is used to stop, enable or disable the reception. Everything can be done with the help of SCON register. Fine. SBUF already nama nariya pesiyachi. Physically there are two SBUF register. Okay, to store the byte received in SBUF read only. See, நீங்க என்ன byte transmit பண்றீங்களோ அது SBUF ல தான் போடணும். Similarly, ஒரு byte of data வந்திருக்குன்னு சொன்னா you have to read the SBUF only. Fine. So serial buffer register, this is the intermediate register used for transmitting the serial data. Fine. SBUF write only for transmitting purpose and SBUF read only for reception purpose. Fine. Then we have one more register, PCON. Actually, this is, we call it as power control register. Power control register. But idhula ulla ore oru bit, SMOD bit abindrathu, it is going to be act as a double baud rate. Okay. Okay. So on the bit na 1 panna appadina na program pannirukka baud rate double agum. 0 panna na enna baud rate program pannano and the baud rate la work agum. That's the meaning for it. Fine. So in the PCON register we are having only one bit, that we call it as SMOD bit. If the SMOD bit is set, the baud rate is going to be double. The SMOD bit is 0, the baud rate is going to be what we have programmed. That's it. Fine. So totally we are having 2 SFR only. The third SFR, it is mainly for power control mode. Fine. See, already we have studied your 8051 microcontroller is having 2 power saving modes. One is idle mode, the other one is power down mode. Fine. So the program pandradhukaga the PCON register, but only one bit in the PCON register, it is used to double the baud. Okay, that we call it as SMOD bit. Fine. Okay, we will go one by one. So first we will go with the SCON register. Fine. So this SCON register, it is going to have a word form as shown below. Fine. SM0, SM1, SM2, then REN, TB8, RB8, TI, RI. So this 8 bits are the format for SCON register. Fine. See, the word format la nama therinja mattumda nama enna panna mudiyum. We can able to program the serial UART of 8051 microcontroller. Like your timer. Timer la rendu format paathom. Enna? To which register we are having the word format? In the case of timer. Rendu register ku mattum word format paathom. Enna? Yes, PCON. What about the other thing? TMOD. Very good. Okay. Similarly, here we have the word format for configuring and controlling the serial port of 8051. Okay. So, idhula ethana bit irukku parunga? 8 bits irukkudu. SM0, SM1, SM2, REN, TB8, RB8, TIR. Okay. So, idhula SM0 and SM1, it is going to be used for mode selection. Fine. Already I have told you how many modes of operations are there in serial UART of 8051. It can be configured in how many different modes? 4 different modes. That's why we are having 2 bits. Using these 2 bits, you can have 4 combinations. Fine. Fine. You have to carefully note down. Idu varaikku nama paatha ella edathiliyum M1 M0 appadha irundhu. Fine. Inge mattum eppadi irukku? 0 1 அப்படி இருக்கு. Fine. You have to carefully note down this. So 0 0 இருந்தா meaning என்ன? Mode 0. 0 1 இருந்தா mode 1. 1 0 இருந்தா mode 2. 1 1 இருந்தா mode 3. Mode 0 அப்படின்னா meaning என்னன்னா shift register mode. What about the name of the mode? Shift register mode. Fine. Is it clear? Shift register mode. If I say mode 0, that means it is going to work as a shift register. That's why it is called as shift register mode. Then mode 1 அப்படினு பார்த்தோம்னா 8 bit UART. Okay, 8 bit UART. Mode 2 அப்படினு பார்த்தோம்னா 9 bit UART. Mode 3 is also 9 bit UART. What about the difference between mode 2 and mode 3? Can you tell me on seeing this diagram, this table? What about the difference between mode 2 and mode 3? Both are going to be 9 bit UART mode. you are only. What about the difference? What about the difference? On seeing the table, you can say. On seeing the table itself, you can say. The table of path is mode 2 9-bit varda, mode 3 9-bit varda. Yes, very good, Shivakumar. In the case of mode 2, it is going to have a fixed baud rate. In the case of mode 3, it is going to be variable baud rate. Fine. The mode of operation, mode 2 and mode 3, both going to be same. ரெண்டுமே ஒரே மாதிரி தான் இருக்க போகுது. ஃபைன். ஒரே ஒரு வித்தியாசம் என்ன? baud rate மட்டும் மாறும். மோட் 3 ன்னு சொன்னா நான் என்ன பண்ணலாம்? I can vary the baud rate. மோட் 2 ன்னு சொன்னா baud rate vary பண்ண முடியும். Similarly, baud rate generation பொறுத்த வரைக்கும் நல்லா கவனிங்க, which two modes are following the same thing? baud rate generation எந்த ரெண்டு மோட்ல சேமா இருக்குன்னு பாருங்க. In which two modes the generation of baud rate is going to be common? Yes, very good. Mode 0 and mode 2 baud rate பொறுத்த வரைக்கும் ஒரே மாதிரி தான் ஜெனரேட் ஆகும். Don't get confused. Mode of operation பொறுத்த வரைக்கும் mode 2 and 3 is going to be same. Fine. Regarding the baud rate, mode 2 and mode 3 following the same method to generate the baud rate. Both are going to be variable baud rate. Fine. Here, you people are told here, it is given by the timer 1 only. The variable baud rate yaar set panna pora? Which timer of 8051 can be used to set the baud rate? We can have a question here. Which timer of 8051 can be used for baud rate generation? Rendu timer da irukku, timer 0, timer 1. Fine. Here itself it is mentioned. Variable baud rate அப்படினு சொன்னா அந்த baud rate generate பண்றதுக்கு எந்த டைமரை யூஸ் பண்ண போறோம்? timer 1 தான் யூஸ் பண்ண போறோம். Fine. Okay. Now coming to the mode 0. Mode 0 பொறுத்த வரைக்கும் என்ன சொல்லிருக்கோம்? Fixed baud rate. That means what? Whatever the operating frequency of your crystal, that is divided by 12. That means here this shift register is operating with the clock of FOC by 12. That means what? For every one machine cycle in mode 0, 1 bit it is going to be transmitted. That's it. Is it clear to everyone? Is it clear to everyone? In the mode na UART the follow up பண்ணுது. Mode 0 it's not about the UART. இங்க start bit stop bit la கிடையாது. Mode 0 பொறுத்த வரைக்கும். Mode 0 it is going to work as a shift register mode. That's all. For every one machine cycle it is going to shift the data bit one by one. நீங்க SBUF ல ஒரு வேல்யூ போடுறீங்க அப்படின்னா இந்த 8 பிட்டும் நமக்கு டிரான்ஸ்மிட் ஆகி முடியற வரைக்கும் நமக்கு இந்த ஆபரேஷன் நடந்துட்டே தான் இருக்கும். It is going to work as only shift register. That's it. Okay. Fine. In the case of mode 2, இங்கேயும் fixed baud rate தான். Fine. இங்க ஆனா baud rate எதை டிபெண்ட் பண்ணி இருக்க போது? Oscillator frequency and S-mod bit. நல்லா கவனிக்கணும். Oscillator bit and oscillator frequency and S-mod bit. What I have told you? S-mod bit 0 அப்படின்னு சொன்னோம்னா FOC by 32. FOC by 64. S-mod bit 1 அப்படின்னு சொன்னோம்னா FOC by 32. Fine. Is it clear? S-mod bit 0 பண்ணிருந்தீங்கன்னா இந்த baud rate ஒர்க் ஆகும். 1 பண்ணிருந்தா இந்த baud rate ஒர்க் ஆகும். This and all we can discuss in detail later. Okay, later point of this slide. Okay. As of now, what we have to know? Using this 2-bit SM0 and SM1, the mode of operation of serial UART can be configured. Out of the 4 modes, any modes you can configure. Fine. The operation of mode 2 and mode 3, it is going to be same only. Fine. Regarding the baud rate, mode 1 and mode 3. Fine. Mode 1 and mode 3. Fine. I think mode 0 and 2 type பண்ணிருக்கீங்க. Shivakumar and Logas Nega. Fine. See, it is regarding the mode 1 and 3. Mode 1 and 3 இருந்தா எனக்கு என்ன சொல்றோம்? Baud rate வந்து timer 1 பேஸ் பண்ணி இருக்கும். Fine. That means the baud rate generation is common for both mode 1 and mode 3. Kindly correct it. Okay. Mode 0 and 2 போட்டுருக்கோம். Actually இங்கே mode 1 and 3. Fine. So இங்கே fixed baud rate வச்சு நீங்க சொல்லிருக்கலாம் maybe, but இங்கே fixed baud rate னு சொன்னாலும் the generation of baud rate is going to be different. when compared with mode 1, sorry, mode 0 and mode 2. Fine? Okay. Now, we will go with the SM2 bit. Listen carefully, it's very, very important. So this, it is not called as mode selection bit. It is termed as multiprocessor communication enabled bit. Multiprocessor communication enabled bit. See, it's a bit different topic. We have to know. Okay. Bit different topic. We have to understand. Okay. As of now, I will told you few things. Okay. Try to understand. SM2 being a multiprocessor communication bit. That means when you are having multiple microcontroller, okay, that are going to communicate serially, this particular bit must be enabled. Fine? Okay, you people try to understand it. Fine? As of now, the word indicates multiprocessor. What it means? Multiple microcontrollers are going to present in the system. Fine? For a particular system, நிறைய மைக்ரோ கண்ட்ரோலர் நம்ம யூஸ் பண்ண போறோம். அதுல சீரியல் கம்யூனிகேஷன் இன்வால்வ் ஆகுது அப்படின்னா, one, it is going to be function as a master. The other thing, it is going to function as a slave. நல்லா புரிஞ்சுக்கணும். ஒரு மைக்ரோ கண்ட்ரோலர் மாஸ்டரா இருக்கணும், மிச்சதெல்லாம் ஸ்லேவா இருக்கணும். That we call it as single master multiple slave அப்படின்னு சொல்லுவோம். What we call it as single master and multiple slave system. Okay. So அதுல அந்த particular operation நான் போறப்ப I have to enable this bit. Fine. So this is set by hardware. Okay, this is set by software, not by hardware. Sorry for that. Slide number 21. It is set by software, not by hardware. Sorry for that. See, programmer only decides whether we are going to use the multiprocessor communication mode or not. Fine. So the set by meaning in it enables the multiprocessor communication mode. Reset meaning in disables the multiprocessor communication mode. Fine. Is it clear to everyone? SM0, SM1 mode of operation choose pandadukku. Fine. Then SM2 it is for multiprocessor communication mode. Fine. One more very important thing I want to say is, if I am configuring one microcontroller, one 80-bit microcontroller as transmitter in particular mode, the other microcontroller must also get configured in the same mode of operation. It's also very, very important. Okay. In mode 0, okay, in the SM2 bit, all mode ko applicable kadayadu. Over mode porthu it is going to vary. Fine. First of all, what we have to know, SM2 அப்படினா multiprocessor communication enabled bit. Set பண்ணா எனக்கு என்ன ஆகும்? Multiprocessor communication mode enable ஆகும். Reset பண்ணா disable ஆகும். Fine? Okay. Regarding mode 0, SM2 bit is not going to be considered. Fine? So SM2 bit must be 0. Meaning என்ன? இந்த ரெண்டு பிட் நான் 00 போட்டாலே SM2 bit கண்டிப்பா என்ன பண்ணி ஆகணும்? 0 தான் போட்டாகும். Fine? Okay. In the case of mode 1, if SM2 bit 1 அப்படினா meaning என்னன்னு பாத்தீங்கன்னா, receive interrupt will not be generated if invalid stop bit is received. Stop bit எனக்கு ப்ராப்பரா வரல. Fine? Stop bit எனக்கு ப்ராப்பரா வரல அப்படின்னா ஆட்டோமேட்டிக்கா என்ன ஆயிடும்? Interrupt generate ஆகுது. Fine? Even though you have received the data, but the stop bit is not valid. Okay. If the stop bit is not valid, interrupt will not be generated. Fine? நல்லா கவனிக்கணும். SM2 1 பண்ணிட்டேன் அப்படின்னா mode 1 பொறுத்த வரைக்கும், regarding mode 1, interrupt will not be generated if stop bit received is not valid. Fine? In mode 2 and 3, mode 2 and 3 already நான் சொல்லிட்டேன், 9-bit UART அப்படின்னு சொல்லிட்டேன். கரெக்டா? அப்படின்னா மீனிங் என்ன? 9th bit ரிசீவ் ஆகிறது கண்டிப்பா எனக்கு 0 இருந்துச்சுன்னா interrupt generate ஆகாது. 1 இருந்தா மட்டும்தான் interrupt generate ஆகும். Is it clear to everyone? Is it clear to everyone? See, இது கொஞ்சம் கன்ஃபியூசிங்கா இருக்கும் அண்டர்ஸ்டாண்ட் பண்ணிக்கிறதுக்கு. But try to read this sentence and understand it. Fine? In mode 0, SM2 bit கண்டிப்பா 0 தான் இருக்கணும். In mode 1, 8-bit UART சொன்னோம் இல்லைங்களா? Fine? 8-bit UART அப்படின்னு சொன்னோம்னா அதுல ரிசீவ் ஆகக்கூடிய ஸ்டாப் பிட் வேலிட் ஸ்டாப் பிட்டா இருந்தா மட்டும்தான் interrupt generate ஆகணும் அப்படின்னா you have to keep SM2 as 1. Fine. SM2 நம்ம 1 வச்சிருந்தா மீனிங் என்ன? SM2 நான் 1 வச்சிருக்கேன் அப்படின்னா மீனிங் என்ன? In the case of mode 1, valid stop bit வந்தா மட்டும்தான் interrupt generate ஆகும். Fine. இது சப்போஸ் நீங்க 0 பண்ணிருந்தீங்கன்னா மீனிங் என்ன? Valid stop bit வரலனாலும் interrupt generate ஆகும். That means the data is provided with an error possibly. Fine. மீனிங் என்ன? இதோட பேர் மல்டி ப்ராசஸர் கம்யூனிகேஷன் எனேபிள் பிட்னு சொன்னாலும் இந்த பர்டிகுலர் மோட்ல இது என்னவா ஒர்க் ஆகும் போது if invalid stop bit is received at that point of time, interrupt will not be generated. Fine. Receive interrupt will not be generated. In mode 2 and 3, it's very very important. 9 bit நமக்கு ரிசீவ் ஆக போகுதுன்னு சொன்னோம், கரெக்ட்டுங்களா? அதுல 9th bit ரிசீவ் ஆகிறது 0வா இருந்தா interrupt generate ஆகாது, 1ஆ இருந்துச்சுன்னா தான் interrupt generate ஆகும். Fine. Fine. Okay. So multiprocessor communication mode na porana generally mode 2 or 3 only I am going to use generally. Fine. With meaning enna na solren, when I am transmitting a data, fine. So here it is going to be differentiated into address and data. Now transmit panna poradhu, see when I say multiprocessor communication means mode means what? Oru master irukku, multiple slave irukku. Appo slave first enna pananum? When we are having multiple slave, how it is going to communicate with only one slave at a time? Any idea? Before start communicating with any one of the slave has to be selected. Correct or not? Is it correct or not? Yes or no? See, single master, multiple slave irukku solrappa. The master endha slave kuda communicate pananum. Adha define pandradhu kandipa enna venum? It need an address. Correct? Yes or no? Yes, definitely yes. Fine. நல்லா ஞாபகம் வச்சுக்கோங்க. மாஸ்டர் சைடுல நல்லா கவனிங்க. மாஸ்டர் சைடுல எனக்கு ஃபர்ஸ்ட் நான் சென்ட் பண்ணக்கூடியது அட்ரஸ் அப்படின்னா the 9th bit it is going to transmit must be 1. நல்லா கவனிக்கணும். மல்டி ப்ராசஸர் கம்யூனிகேஷன் மோட்ல 9th bit transmit பண்ண போறது 1ஆ இருந்தா it is going to be address. அப்படின்னா மீனிங் என்ன? எல்லா மைக்ரோ கண்ட்ரோலருக்கும் நம்ம டிரான்ஸ்மிட் பண்ணக்கூடிய 8 bit டேட்டா போகும் with 9th bit as 1. 9th bit 1ஆ இருந்தா கண்டிப்பா என்ன ஆகும்னு சொல்லியிருக்கோம், interrupt generate ஆகும். That means whenever you send an address, all the microcontroller will get interrupt. Is it clear or not? கொஞ்சம் கேர்ஃபுல்லா கவனிங்க. இது கேர்ஃபுல்லா கவனிச்சா மட்டும்தான் புரியும். SM2 bit நான் 1 பண்ணியிருக்கேன் அப்படின்னா மீனிங் என்ன? மல்டி ப்ராசஸர் கம்யூனிகேஷன் மோட் நம்ம எனேபிள் பண்ணியிருக்கோம். Fine. In the case of mode 2 and 3, we are having 9 bit UART. 9th bit என்ன அப்படின்னு பாத்தீங்கன்னா it is going to be either 0 or 1. Correct? இப்போ நான் என்ன சொல்றேன், 9th bit 1 along with data நான் சென்ட் பண்ணேன் அப்படின்னா மீனிங் என்ன? It is going to be considered as an address. Fine. If I send an 8 bit data with 9th bit as 1, 9th bit நான் செட் பண்ணி அனுப்புறேன் அப்படின்னா மீனிங் என்ன? All the microcontroller will get receiving. Is it true or not? Yes or no? Yes or no? Yes or no? No response from you people. See, the multiprocessor communication mode அப்படின்னு சொன்னா SM2 bit கண்டிப்பா செட் பண்ணிருக்கணும். That's very first point. Fine. Multiprocessor communication mode அப்படின்னு சொன்னா single master multiple slave. ஒரு மைக்ரோ கண்ட்ரோலர் மாஸ்டரா இருக்கும், வித் எல்லா மைக்ரோ கண்ட்ரோலரும் ஸ்லேவா இருக்கும். Fine. So when a master microcontroller want to communicate with the slave microcontroller, it has to send the address. Fine. Address send பண்றதா இருந்தால் 9th bit கண்டிப்பா என்ன இருக்கணும்? 1. மீனிங் என்ன? When it is transmitting the address, all the microcontroller will get interrupt. Why? 9th bit 1. 9th bit 1 இருந்தாலே receive interrupt generate ஆயிடும். கரெக்டா? Yes or no? ஓகே ஃபைன். இப்போ எல்லா மைக்ரோ கண்ட்ரோலருக்கும் அட்ரஸ் போயிடுச்சு. கரெக்டா? எல்லா ஸ்லேவ் மைக்ரோ கண்ட்ரோலருக்கும் அட்ரஸ் போயிடுச்சு. விச் ஒன் ஐ ஹாவ் அட்ரஸ்? அதுக்குன்னு ஒரு அட்ரஸை நம்ம ப்ரீ டிஃபைன்டா ப்ரோக்ராம் பண்ணி வச்சிருக்கோம். Which microcontroller address is matching with the address sent by the master that exits from the multiprocessor communication mode. நல்லா கவனிக்கணும். மித்த எல்லா மைக்ரோ கண்ட்ரோலரும் மல்டிப்ராசஸர் கம்யூனிகேஷன் மோட்ல தான் இருக்கும். ஃபைன். எந்த மைக்ரோ கண்ட்ரோலர் மட்டும் மல்டிப்ராசஸர் கம்யூனிகேஷன் மோட்ல இருந்து வெளியில வந்துரும்? The particular slave microcontroller it address. fine. Now இதுக்கப்புறம் டேட்டா சென்ட் பண்ண போறதா இருந்தா என்னோட மாஸ்டர் என்ன பண்ணும், 9th bit 0 வச்சு சென்ட் பண்ணும். What it mean? If the 9th bit is 0, multiprocessor communication mode உள்ள மைக்ரோ கண்ட்ரோலருக்கு இன்டரப்ட் ஜெனரேட்டே ஆகாது. ஆனா எந்த மைக்ரோ கண்ட்ரோலர் என்னோட மல்டிப்ராசஸர் கம்யூனிகேஷன் மோட்ல இருந்து வெளியில வந்திருக்கோ அதுக்கு மட்டும் இன்டரப்ட் ஜெனரேட் ஆகும். பிகாஸ் இட் ஹாஸ் எக்ஸிட்டட் ஃப்ரம் தி மல்டிப்ராசஸர் கம்யூனிகேஷன் மோட். ஃபைன். சிம்பிளா சொல்லணும்னா எல்லா மைக்ரோ கண்ட்ரோலருக்கும் ஃபர்ஸ்ட் அட்ரஸை சென்ட் பண்ணுவோம். எது அட்ரஸ் ப்ராப்பரா மேட்ச் ஆகுதோ அது மட்டும் என்ன ஆகும், SM2 பிட்டை ரீசெட் பண்ணிடும். That means whenever your master is going to send the data with 9th bit as 0, other microcontroller will not be interrupted. Is it clear to everyone? Is it clear now to everyone? ஒரு மாஸ்டர் நிறைய ஸ்லேவ் இருக்கு. மாஸ்டர் அட்ரஸ் சென்ட் பண்றப்ப 9th bit 1 வச்சு சென்ட் பண்ணும். ஸோ எல்லா பர்டிகுலர் மைக்ரோ கண்ட்ரோலர் ஸ்லேவும் இன்டரப்ட் ஆகும். கரெக்ட். அதுல எதோட அட்ரஸ் மேட்ச் ஆகுதோ அதை SM2 பிட்டை கிளியர் பண்ணிக்கும். அப்ப மீனிங் என்ன, அடுத்த தடவை நான் டேட்டா சென்ட் பண்றப்ப என்னோட மாஸ்டர் டேட்டா சென்ட் பண்றப்ப 9th bit 0 வச்சு சென்ட் பண்ணும். If the 9th bit is sent as 0 to all the slave, எல்லாமே மல்டிப்ராசஸர் கம்யூனிகேஷன் மோட்ல இருக்கு. 9th bit 0 வந்தா என்ன சொல்லியிருக்கேன், இன்டரப்ட் ஜெனரேட் ஆகாது. எதுக்கெல்லாம், எதெல்லாம் அட்ரஸ் மேட்ச் ஆகுதோ அந்த எல்லா மைக்ரோ கண்ட்ரோலருக்கும் இன்டரப்ட் ஜெனரேட் ஆகும். எதுக்கு மட்டும் இன்டரப்ட் ஜெனரேட் ஆகும்? The one which I have addressed previously. Fine. I hope it is clear to everyone. Fine. Now coming to REN. இந்த பிட்டை நான் 1 பண்ணேன் அப்படின்னா ரிசப்ஷன் எனேபிள் பண்றேன்னு அர்த்தம். 0 பண்ணோம் அப்படின்னா ரிசப்ஷனை டிசேபிள் பண்றேன்னு அர்த்தம். Fine. This is also done by the software only. Sorry for that. So this is also done by the software only. Okay, fine. So 1 அப்படின்னா மீனிங் என்ன, ரிசப்ஷன் எனேபிள். 0 அப்படின்னா ரிசப்ஷன் டிசேபிள். That's all. Fine. So I hope this 4 bits are clear now. SM2 கொஞ்சம் புரிஞ்சுக்கிறதுக்கு கஷ்டமா இருக்கலாம், but try to read again and again so that you can understand. Fine. Multiprocessor communication mode சொல்றப்ப master is going to send the data with 9th bit as 1 அப்படின்னா that is going to be considered as address. Address எல்லா மைக்ரோகண்ட்ரோலருக்கும் போகும். Which microcontroller is matched with the address, it will reset the SM2 bit automatically. Program எழுதிருப்போம். Fine. So அந்த பர்டிகுலர் மைக்ரோகண்ட்ரோலர் மட்டும் மல்டிப்ராசஸர் கம்யூனிகேஷன் மோட்ல இருந்து வெளியில வந்தாச்சு. Now the master is going to send the data with 9th bit as 0. Fine. That is going to be considered as data. So no microcontroller will be interrupted except the address one. Fine. Okay. Now TB8 அப்படின்னா ஒன்றும் கிடையாதுப்பா. 9-bit UART mode, the 9th bit what we are going to transmit, that is going to be put here. 9th bit na transmit panna poradhu inda particular TB8 bit la na elidhirukken. Fine. Then RB8 அப்படிங்கிறது the 9th bit it is going to receive in mode 2 and 3. The 9th bit it is going to receive in mode 1. Stop bit inge receive aayir. Fine. Then PI. Fine. These two are set by hardware, cleared by software. Kindly understand me. TI அப்படின்னா மீனிங் என்ன, transmit interrupt. Once நீங்க எழுதுன அந்த SBUF ல எழுதுன டேட்டா டிரான்ஸ்மிட் ஆகி முடிஞ்ச உடனே this flag will get set automatically. Transmission முடிஞ்சிருச்சு அப்படின்னா இந்த flag செட் ஆகும் TI. Fine. Similarly RI, இது எதுக்காக RI, reception நடந்துச்சுன்னா இந்த பிட் ஆட்டோமேட்டிக்கலா செட் ஆயிடும். Fine. நல்லா கவனிக்கணும். செட் பை ஹார்ட்வேர், கிளியர் பை சாஃப்ட்வேர். மீனிங் புரிஞ்சுக்கணும். ஃபைன். ஓகே. How many interrupt we are having totally? 5 interrupt. External interrupt 0, external interrupt 1, timer overflow interrupt 0, timer overflow interrupt 1, serial interrupt ஒன்னு தான் இருக்கு. கரெக்ட்டா? But we are having 2 sources for that. One is by transmission completion or reception. ஏதோ ஒன்னதுனால தான் நமக்கு என்ன ஆகுது, இன்டரப்ட் நடக்குது. ஃபைன். ஸோ இப்போ எதனால நடக்குதுன்றது நமக்கு தெரியாது. ஃபைன். இன் அதர் கேசஸ், இன் அதர் இன்டரப்ட்ஸ், the corresponding interrupt flag will get reset automatically once it goes into the ISR. Fine. In the case of serial communication, the programmer has to reset it. Transmission-னால இந்த interrupt வந்திருக்கா, reception-னால இந்த interrupt வந்திருக்கான்றத ISR-ல செக் பண்ணணும். Fine. After you have checked, Whether it is due to transmission, you have to clear the EIP. Whether it is due to reception, you have to clear the RIP. That's it. Fine. இங்க ஒரு பாயிண்ட் மென்ஷன் பண்ணிருக்கோம். எப்ப வந்து இந்த பிட் செட் ஆகும் அப்படின்னு பாத்தீங்கன்னா மோட் 0 பொறுத்த வரைக்கும் 8th பிட்டோட எண்ட் ஆஃப் டிரான்ஸ்மிஷன். Regarding mode 1, 2 and 3, beginning of the stop. Similarly, இங்க நம்ம மென்ஷன் பண்ணிருக்கோம். In mode 0, end of the 8th bit received. இங்க என்ன சொல்லிருக்கோம்? Halfway through the stop. Fine. That's all about the SCON register. I hope time is 11 o'clock. We can stop here with it. Fine. Thank you, students. So here we will stop with it. The remaining thing we can continue in the next session. Okay. Thank you to everyone. I'm going to stop the recording.